This is probably the most common mistake I saw when I was doing biostats. Median splits. When I worked at a biostatistician, it was very common to collaborate with other biostatisticians, and there was one woman by the name of Barbara. She was like 75 years old, very experienced and very awesome. And one day, her and I were just kind of chilling, shooting the breeze. And I asked her, what is your biggest gripe about how people do data analysis? And I even said, all right, let's say it at the same time. 1, 2, 3. And we both said it at the same time, median splits. Yeah, it kind of drives me crazy. Let's say you have a continuous variable like biomarker level. I used to do a lot of research in lupus stuff and trying to figure out from biomarkers best ways to predict who gets lupus. And so I might show a graph like this and say this is the biomarker level of all of our patients. And so inevitably the doctor would ask,
okay, so what's positive?
What?
What value do they become positive?
It's a continuous variable. It doesn't make sense to talk about positive.
Yeah, but what's the optimal cutoff?
Optimal for what?
I don't know. Optimal.
Well, maybe we put the cutoff here, or here, or here, or here, or here. It doesn't matter. Wherever you put it, it's going to be weird because it's a continuous distribution. So that's one way that you see that happening is somebody wants to know, okay, what is considered positive? But I also saw it in other ways. So let's say you have a model predicting how long their hospital stay is based on their gender and whether they are using steroids as medication and interferon beta, which is a cytokine. And I don't know what any of those words mean. But they're some sort of biomarkers. I know what a biomarker is. Hey, I learned something as a biostatistician. In the original model, interferon beta was a continuous variable. But without fail, they always wanted me to cut it and split it into high versus low. Why? I don't know. And so they have this, they're like butchers. They always want to hack things. They always want to cut things in half. They always want to massacre data and serve it so it's more palatable, I guess. Now I'm just taking it too far. Yeah. People frequently want to take this beautiful, complete, continuous distribution and then separate it into high versus low, and it's just weird. It's a bad idea.
Why is it a bad idea?
I don't have my hat, so I can't do that character. Oh well. It's a bad idea. Let's think about it this way. Let me ask you, how tall is tall? You've got an answer? Is it 5'8"? 5'11"? 6 feet? 6'5"? 7 feet? 8 feet? 9 feet? 10 feet? 11 feet? How tall is tall? And you're probably saying to yourself, that's a stupid question. Yeah, it is. But let's just pretend for the sake of something that we decide, all right, everyone below 6 feet is considered short. If you are above 6 feet, you are tall. What does that mean? All right, so that means everybody below 6 feet gets the same score on that variable, tallness or height or whatever. So you mean to tell me that a dude who is 5'11" is considered the same height as a 3'11" child? That doesn't make sense. And yet, that's what we do to our variables when we do a median split. Whatever cutoff we do is going to be arbitrary, and it's going to cluster a bunch of people together that really don't belong together. And you mean to tell me that a 5'11" dude is very, very different from a 6 foot tall dude? Or a 6 foot tall girl? No! They're practically the same height, and yet in the way that we have cut the distribution, we are saying that they are very different. That doesn't make sense. You've got this beautiful, complete data that is continuous, that has feet and inches, and for my non-American / there's There's one other country that uses feet and inches. What is that? Gonna look it up. I have Google in front of me. For my Liberian and Myanmaran, if you are Myanmaran and I am butchering the way that I talk about you, let me know. So for our non-US Liberia and Myanmaran friends, I had totally lost my train of thought. Anyway, I don't even know how many meters 5 feet 11 is. I suppose I could look that up, but I'm too lazy. Anyway, we have this beautiful metric that tells us continuously everybody's height. Why would you then discretize it or categorize it as high versus low? It doesn't make sense. And so that's conceptually what you're doing and why it's a bad idea, but let me talk about these statistical problems. The first statistical problem is it introduces unreliability. And reliability is consistency of measure, and you are inducing inconsistency or imprecision. So, like I said earlier, you're categorizing somebody who's 3'11" the same height as somebody who's 5'11". That's very imprecise to say that they are the same height. And anytime you introduce unreliability or imprecision, you are going to affect your effect sizes. So that's the number 2 problem. If you discretize or if you categorize a continuous variable, it's going to reduce the size of your effect size. So you might get a statistical effect that would be pretty impressive, but now it's practically zero because you've got all this unreliability you've introduced. And again, that's because you're introducing noise in the data. Completely unnecessary noise. And when there's a lot of noise in the data, it makes it much harder to find the effect. So that's why your effect sizes get reduced. And so you might be saying to yourself, well, it's worth the cost. Well, I don't mind being conservative when I'm doing data analysis. I'll go ahead and take my median splits. Yeah, still a bad idea, because that's not always the case. There's a paper written in 1993 by Maxwell and Delaney who demonstrated that for multivariate models. So if you have 2 predictor variables, especially if you're looking at interaction effects, if I remember right, it's been a while since I've read the paper. Haven't read it since graduate school. But anyway, if you're modeling multiple variables, you can actually get instances where you're inflating the effect size.
Well, that sucks.
So categorizing data when it's continuous is a very bad idea. Why do people do it then? If it is inarguably a very bad idea, why do people do it? Well, it wouldn't be the first time that people do stupid things with data, despite it being a very bad idea. So that probably shouldn't surprise you. But I've got a theory, and I think I remember hearing this theory many years ago. I wish I could find a reference, but somebody was making the argument that language is by nature categorical, if that makes sense. So if I think about the word computer, it's not like I can 80% say the word compute. That would be weird. I mean, language is categorical. It fits into discrete categories. And so what that means is that our way of communicating is categorical. When we are talking to another person, we can only speak in categorical terms because the language is categorical. And likewise, when we are interpreting events that happen in the real world, our brain is talking to ourselves. We are talking to ourselves using language. And so when we interpret the world, we have to interpret it categorically because that's how our brain works. And this happens even though the world that we see is continuous. If our ancestors went out and saw a tiger, they're going to see it continuously. In other words, its size is going to be shown to us continuously. It's going to be exactly 6 feet 4 inches long. I actually have no idea how big tigers are, but let's just say 6 feet 4 inches. But when we are interpreting that, and when we are thinking about how we're going to tell our villagers when we get back home, we don't say 6 feet 4 inches. We say that was a big ass tiger. So our brains are always trying to language-atize information. Language-atize. Categorize. I like language-atize better. And that's the idea. Because we use language to communicate and language is categorical, then we have to think categorically. Or we take continuous information and it's our nature to categorize it. It'd be cool if we could create languages that are continuous. Like what would that even look like? I guess we could use like inflection and tone to communicate continuous information. So we'd say that was a big ass tiger. And then depending on how long and how high you went, that would communicate how big it was. Hey, we should start a new language that does that. Deal? All right. So I think that's really the root of the reason that we just have categorical language, and it's our nature to want to categorize things. But there's also other reasons, some of them more practical. Some analyses are much easier to understand when you do that categorically. So let's say we have two predictors: speed of an object and softness. Let's say you're trying to figure out how much damage a crash test dummy receives depending on how fast they are flying through the air and how soft the material is that they hit, I guess. So we build a model trying to predict damage to our crash test dummy based on the speed that they are flying through the air. I just have this image of a crash test dummy flying through the air, and I don't know, it's just hilarious to me. Anyway, we throw them at various speeds and at various targets that vary in softness, and we're interested in determining the damage from, let's say, an interaction effect sort of models. So we've got a speed effect, a softness effect, and then the interaction between the two. And if we were to look at a regression table and try to interpret that, especially the interaction, negative 0.08, what is that telling us? That is telling us that every time the product of speed and softness increases by 1 unit, we expect damage to decrease by 0.08 points, holding other things constant. So I gave you the interpretation of what that is, but I have no idea what it means. I can't interpret that value before. Like, what does it even mean to hold the other things constant? You can't hold them constant because it's an interaction effect. Yeah, this is really hard to interpret. I've never been able to interpret an interaction term between two continuous variables. I just don't have an intuition for what that means. So naturally, you might want to categorize it. And so you might compute means, for example. And so you compute the main effect of speed. And look at that, there is a damage difference of about 6 points. And then you compute a main effect of softness, and look at that, there's a difference of about 12 points. And then maybe you even look at the cell means, we would call them, and maybe be able to make sense of that. I can't. Well, I could if I thought about it, but I don't have the mental desire or stamina to interpret that right now. So I'd rather look at a plot. So I might look at this and say, hey, look at that. On average, higher speeds mean more damage, and on average, that doesn't make sense. I simulated these data, and it doesn't make sense that softness has higher damage than hardness. Anyway, let's just pretend we reverse labels. But anyway, you see that there is effect of softness, and it seems that having a high speed exacerbates the problem of running into a hard material. So that kind of makes sense. So we can interpret that, and we use categorization to help us interpret that. But it's really not necessary. You could leave it continuous and still be able to interpret it. And so a visual might look like this. And this visual is just telling us that, across all levels of hardness and softness, increasing the speed increases the damage. But that effect is much more drastic when you have a hard material, which makes sense. Again, assuming I flip the labels and softness actually means hardness, I guess. Anyway, now you might be screaming at the screen saying, hey, QuantPsych dude, yeah, didn't you just categorize a variable in your plot? Yeah, I did. So? Well, aren't you saying you shouldn't categorize continuous data? Well, yeah, I did say that, I guess. Interesting. Weird. And I'll talk more about this later. But the basic idea is that we are categorizing it, but just for the visuals. We're not doing it for the actual analysis. So we leave the analysis continuous, but for our visuals, we discretize them, languageatize them, categorize them. And like I said, we'll talk more about that in a bit. Reason number 2 or 3, whatever we're on, that people discretize data. It allows them to use analyses that they're familiar with. So if you really suck at statistics and you only know how to do an ANOVA and you have continuous data, you might be tempted to turn it into categorical data so you could use your ANOVA. I think this goes without saying that that's a really stupid idea. Don't do that, please. That's like saying, hey, I don't know how to drive a stick shift, so I'm just going to stay in first gear. No. You are not leveraging the advantage of a stick shift. You need to... Yeah, don't do that. That's a bad idea. That's all I got to say about that. Reason number 3 or 4, whatever I'm on. Sometimes when you do an analysis, at the end of the day, you have to make a decision. So, should this patient be hospitalized? Should insurance cover this procedure? Or should this person be medicated? What is the meaning of life?
What is the meaning of life?
Okay, that last one doesn't make sense. And so at the end of the day, we need to make a decision. And if we're making a decision, we have to categorize things. And I would say that's fine, but reserve it for the end of the analysis. So we don't categorize as we're doing the analysis. It's only when we are summarizing our conclusions and showing the dependent variable or whatever, then we might want to do that. And I would also say anytime you do have to do this, present it alongside the continuous data. That's kind of a best of both worlds situation, that you present the continuous data and you present the diagnosis or high versus low or whatever. Now, you might be asking yourself, hey man, is there ever a situation where it's justified to do the whole categorizing thing? I would say, yeah, there are 2 situations. One of them is if the underlying variable is actually categorical. This was the first time in my career I've actually run into a situation where it made sense. And basically, the measure was a sexual assault measure that was basically asking, have you ever sexually assaulted someone? And how much did you sexually assault them? And so there were varying degrees of sexual assault. And so in this situation, it kind of does make sense but only because you're asking 2 questions at the same time. A, did you ever sexually assault somebody? And then B, how much did you sexually assault them? And so you might see data like this. We would probably call this zero-inflated data. Kind of, sort of. That's one of those technical notes that maybe I'll put in the description of what I mean here because I don't want to get sidetracked on that. Anyway, so in that situation, maybe it's justified to categorize it and just say, all right, if you did assault versus not, and then ignore the continuous information, if that's of interest to your model. The other situation is one that I talked about already, where we're visualizing things. And again, let me be emphatically clear that when I say categorizing for the visualizations, that's just for the visualization. So when we fit the model, we fit the continuous data. But then when we're trying to visualize what the model is telling us, that's when we use categorization. And that's kind of necessary because our brains are very limited. We can't really visualize 4 continuous variables at a time. And even 3 is hard. So let's look at an example of a 3-dimensional plot. So this 3-dimensional plot has 3 axes or 3 dimensions. And in order for you to interpret them all together, A, it requires a lot of effort, and B, it requires rotation. So you need to be able to rotate the view so you can understand what's going on. This is a really bad way of visualizing the relationship between 3 continuous variables. Instead, it's much easier and more intuitive to compress that data into 2-dimensional spaces. For example, we might use different colors, lines, and symbols like this. In this case, we have to categorize willpower in this case. So we've got low, medium, and high willpower. Or we could also compress that in 2-dimensional spaces by using paneling, like in this example, where again, we have low, medium, and high. But of course, when you do that, there is the risk that you are oversimplifying things and that there's some important pattern that you miss. And so for this reason, it's always a good idea to kind of flip the axes. So in this case, we have damage resistance on the x-axis and then willpower paneled. It might be a good idea to flip those so that we have something like this, where willpower is on the x-axis and now damage resistance is the one that is paneled or shown as a separate line, color, and symbol. And by kind of rotating, I use the word rotated. By rotating your view of the data, you can be more confident that you're not making false assumptions because you're looking at discretized or categorized data. So yeah, those are the only 2 situations that make sense to categorize data. Otherwise, just leave it as continuous. And if you are struggling to figure out how to analyze continuous information, guess what? I'm kind of good at that. And I teach other people to be good at that. So if you want to take a class with me and learn how to do that sort of thing, where you interpret things continuously, please visit my website, simplistics.net, where you can take live classes where you have interaction with me. We're actually tomorrow, based on when I'm recording right now, tomorrow I get to teach my last class of my first live class, and it's been amazing. It's been great. Get to interact with you guys and answer questions and walk through examples and that sort of thing. It's awesome. And of course, if your schedule doesn't align with mine, you're welcome to, by the way, you're welcome to post a comment and say, hey, I would love to take a live class from you, but this particular time doesn't work. That's totally cool. Suggest other times. I'm open. But you could also do self-guided courses where you get access to my Canvas course and quizzes and discussion boards, and you get interaction with me via typing, where we can communicate through typing. I can answer discussion board questions, and you get to go at your own pace. So if you're interested, check out simplistics.net. And yeah, so to summarize, median splits or any sort of categorization of continuous data is a stupid idea, and don't do it. Otherwise, you will be punished by the statistical gods and sacrificed on an altar that looks like the symbol pi. That just got really weird and morbid. Anyway, peace out.